last few years, I've been working here at Swinburne with Professor Ronald Barvet and Associate Professor Enzo Palombo in conjunction with Dr Joe Penozo from the Department of Environment and Primary Industries, or the DPI. We've been working on a project that has been supported by the Australian Research Council on looking at the antimicrobial activity of a group of proteins that are found in wheat plants. So antimicrobial proteins are found in all plants, and they're also found in humans, either as antimicrobial proteins or as other versions of them called short antimicrobial peptides. The reason that we focused on wheat here is that it's such an important commercial crop in Australia. Pathogens that infect plants obviously affect the crop yield and also the quality of the grain that we get. So treatment, particularly using natural products of these crops, is very important commercially for the the wheat industry in Australia. There are two main aspects of our project. One was to work on the actual protein itself from the wheat seeds, and the other one was to actually see how it was actually working. So you've got in your seed everything in a wheat seed to make a potential wheat plant. So we only want one single protein out of this, so we have to get rid of everything else through a process of elimination, basically. So it's a purification procedure which involves basically crushing up the wheat seeds and then extracting that one compound that we want out at the end. From that, we can actually use that to test its activity. So can it actually kill bacteria and fungi? And then we can study how it actually works. So one of the most important features that we've found about these antimicrobial peptides is that they're selective for bacterial cells, and that they don't actually harm or kill human cells in any way. So we can use them as therapeutic agents because of this very important feature. So particularly in hospital situations, so you've got antibiotic resistant bacteria, and particularly things like golden staph, MRSA, bacteria that are resistant to pretty much all our known antibacterial agents, those being the antibiotics. So there is a search in a lot of areas for new sources of antibiotics or new classes of antimicrobial agents to combat this resistance that we currently are facing. Yes, I'm excited about the work I'm doing here at Swinburne. I think it has very important commercial and medical applications for both in crop protection and also the commercial aspect as far as medical applications goes. Antibiotic resistance is a threat that we're facing currently, and I think it's something that we're going to continue to face into the future. So it's early days, but I'm really excited about what the future could hold for this sort of research.